All right, last week we were looking at these epsilon delta, okay? So first off, can you say the limit of definition? Don't flip your notes. Do you remember it? The limit of f of x as x approaches, x is, the limit of f of x is L as x approaches C if, what? See if we can,
If that E thing is.
that E thing is, so if epsilon is greater than 0,
Then whatever the other thing is.
then there exists a delta greater than 0 such that if x minus c is less than delta, then f of x minus L is less than epsilon. That is our, where's it at? We have it on here somewhere. There we go. There is our, for every epsilon greater than 0, there exists a delta greater than 0 such that if absolute value of x minus c is less than delta, then f of x minus L is less than epsilon. And really, this part right here is kind of what we were doing on the homework, right? We were looking at starting with f of x minus L and trying to end up at x minus c, right? So that's what we were kind of looking at before. So when we do that, we'd start off with f of x minus L, simplify it, try to get down to x minus 2 to find what we're looking at, right? All right, so we did some of those. Let's look at this one. So, oh, where is it? Limit as, this is not the one on your, this is from the notes, isn't it? What's the one on your homework in front of you?
When x squared is equal to 9.
So this is 3?
Yeah.
Okay. So that's the one that's on your homework, right? So let's talk about this one. So what we would do here is this would be x squared minus 9 is less than epsilon. And what we're trying to get to, because it's x approaches 3, is we're trying to get to there, right? So what can we do? Well, x squared minus 9, I can factor into x plus 3, x minus 3. And we're trying to get to that x minus 3, so what can we do with this part here? That's what we want to talk about, right? Now, if you remember, we did the one last time. Where we said the bottom got close to 9. But we didn't know if it's a little bit, as this got close to 2, we didn't know if this x was a little bit bigger than 2, a little bit smaller than 2. So we said if this is 9, it could be bigger or smaller than that. So we went bigger, and then we multiplied by 10. Same kind of thing is going to happen here. This x, as x gets close to 3, this is going to be about 6, right? As x gets close to 3, x plus is going to get close to that. So this is about 6, but this could be 5.9, 6.1. It could be somewhere like that. So we're going to divide. But what number do we divide by? We don't want to divide by 6. Could be a little bit bigger 6. Could be a little smaller than 6. We don't want to divide by 6, even though this is getting closer to 6. We want to make this side smaller. So if you want it smaller, do you divide by a bigger number or a smaller number? Bigger. So we're going to divide by, well, we're going to think whole numbers. 7. Same like the other one. So that same idea, you're going to go by a bigger number to do that, okay? All right, I don't want to spend too much time on that. That's the set, your other one on your homework also worked the same way. But, all right. Let's consider these graphs. I have them. So if we consider these two graphs, let's look over here on the left. What is f of 2 on this graph? Open circle. There is no point, so that doesn't exist, does it? Over here, what is f of 2? 2. That makes sense with the open circle, how it doesn't exist. Now, what is the limit of f of x as x approaches 2? So if I look at this graph and imagine for a second there's a person on the graph, and as they're walking close to x equals 2, what are they getting close to? 1. And from the other way, they are getting close to 1. So this limit is 1. Even though it doesn't exist at 2, the limit exists at 2. Now, what about over here? The functional value exists and is 2. But what's the limit as x approaches 2? It's 1. It's the same thing. So you can have graphs where the function of value doesn't exist. You can have graphs where the function of value exists, the limit exists, but they're different. All these things can happen as we look at the graphs and we're trying to find limits. Okay? Now, for example, let's say we look at both of these out here. What is f of 4 in both of them? 2. And the limit as x approaches 4 is also 2, right? So you have all these different things that can happen. Limit and the function are the same. Function doesn't exist, but the limit does. Function exists, but it's different than the limit based on the graph. So let's say we have a graph. Try those three. Take a second, see if you can do those three. The limit of f of x as x approaches 3, the limit of f of x as x approaches 2, and the limit of f of x as x approaches 1. All right, what is the limit of f of x as x approaches 3? 2, exactly. The limit as x approaches 2? 1. What about the limit as x approaches 1? 0. What does D and E stand for? Does not exist. Now, the reason is, if you are approaching from this way, what is it getting close to? 1. But if you approach from this way, it's approaching 0. Which leads us to a new thing, which are one-sided limits. So the one-sided limit, a right-hand limit of the function, we write this as the limit of f of x as x approaches c from the plus, and that equals 0. So that's as you approach from the right. Now, understand, if you're approaching from the right hand limit, right, you're actually moving like left, but you're approaching from the right side. And then we have a left-hand limit, which we have the minus, which you're approaching from the left side, but you're moving towards the right, but you're approaching from the left. And so this means what happens to the function as it's close to what? As x gets close to c from that side. We could get into the whole epsilon delta thing again here with these kind of limits, but we're not going to. We've talked about that already. Okay. So what that does is as we look at these limits here, if I'm now at 1, the minus, is from the left. So at 1, from the left, it's going to 0. 1 from the right is going to 1. Now, if you look at something like at the top, what's the limit of f of x as x approaches 3 from the right? That's still 2, right? And what if that was a minus? It would still be 2. And what if there was no plus or minus there? It would still be 2. But when you look at 1, you get one answer from the left, one answer from the right, and then it doesn't exist at that point. Okay. What about 4 from the left? 1. What about 4 from the right? Does not exist. You also can say like no solution, whatever you want to write. Because can you approach it from the right? There's nothing there. So you can't do that. Okay. And this is going to lead us to our first theorem. Oop. Let me go back. Doesn't look right. So let me fix it. Not sure why it didn't. This is theorem 3. Now, it's on your notes as theorem 3. That's what they call it in the book, theorem 3. We're never going to remember theorem 3. So I call this theorem Bob. We had to give it a name, so I gave it the name Bob. And you'll see why I call it theorem Bob. We use this a lot, so we want to give it a name that we could remember, which is Bob, and I'll explain why I call it Bob here in a second also. So here's what it says. If the limit of f of x as x approaches c is equal to L. So you have a limit at a number, right? If you look at the graph we just looked at, the limit at 3, it was 2. We had a number. That is true if and only if. Do you remember if and only if? That's on the back wall back there. If and only if. Do you remember that from geometry when you looked at theorems? If and only if. If and only if things work both ways. Right? It's true either way in the expression. So, the limit of f of x as x approaches L, as approaches c is equal to L, if and only if the limit from the left is equal to the limit from the right, and they also equal the same thing. Okay. So, as we look at this example, does the limit exist at 1? If we go back here, did our limit exist at 1? No. Why not? Because the limit from the right and the limit from the left were not equal, right? Therefore, it doesn't exist. The limit at 3 was the same from the right and from the left, so it exists. The limit at 2 was the same from the right and from the left. So what theorem Bob tells us is our limit only exists if the limit from the right and the limit from the left are the same thing. And hence why I call it theorem Bob. Because if you read Bob from the left or the right, what is it? Same thing. So it's the same either way. And that's what this theorem says. If you have a limit from the right or from the left, they have to be the same for the limit to exist at a point. So if you look at a graph and there is not a limit from the right and from the left, then it doesn't exist. Okay. All right. Let's look at a couple examples here of this. This is your homework here is going to be some delta math. So let's look at some examples here. So if you look at that, what is, I don't know if you can see it back there, what is the limit of f of x as x approaches -2 with the little plus means from the right? So what is that as you approach from the right? Can you see it? From back?
Solution,
Why no solution?
because it's the open G. And they're not the same. Maybe.
What do you think? Think of it this way. As you approach -2 from the right, does the graph get close to a value? It gets close to -6. So that's the limit. Does it ever get to -6? No, it's an open circle. But that as we get closer and closer to -2, it's getting closer and closer to -6. Does the limit at -2 exist? Why not?
Open circle.
No.
Oh,
There is no solution.
oh.
Why is there no solution at 2? By theorem Bob, the limit from the left and the limit from the right have to be the same. Do you have, what's the limit from the left? 4. So they're not the same. So the limit at 2 doesn't exist. All right, let's do new problem. What is the limit of 4 from the left?
The 4.
Is from the left the closed dot or the open dot? Which one's from the left?
Oh, it would be the closed.
It'd be the closed dot, so it'd be 6. Good. What is f of -2?
-6.
Why?
Because that arrow came from that side.
So let me see if I can write. So let's see. Let me see. Can I write on here? Let's say I have this. We have 4 things here we have to talk about. So we have the limit at -2. Does that limit exist? From the left and right, do they go to the same thing? Let's think of another way. What is the limit from the right? As you approach from the right, what does it go to? -5. As you approach from the left, it goes to -6. Because those are different, does the limit exist at -2? No. Why? By theorem Bob. Does this have a functional value at 2, -2? No. There's no like solid closed dot. Okay? Now, let's say this. Let's get rid of this. And let's say hypothetically that was a solid dot. Now what would f of -2 be? -5. And would any of the other three limit things change? No. Okay. All right. Let's try another one. See if I can erase this. F of -4.
6.
6, because that's the closed dot. Try to get another limit one. Nope, let's not do that one. There we go. What about f of x at -4 plus?
-6.
Because it's from the right, so it goes to -6. Okay. Is that making more sense? Let's try another one. From the right, -1 would be 2.
Yeah.
So, all right, let's go. So here's the graph. So we'll just kind of talk about these. And if you can see it up there, what is the limit at -3 from the left? -3 from the left. 6. What about -3 from the right?
6.
2. From the left. Oh, wait, I'm sorry. I'm about the wrong one. You guys were right. -3. Oh, we did the first one. What's -3 from the left?
6.
Yeah, 5.
5. What's -3 from the right? 5. What's the limit at -3?
6. No.
What's the limit at -3?
5.
If the left and the right are both 5, by theorem Bob, what does the limit have to be at -3? 5. If the left and the right are the same, that's also the limit there. But what is -3? 6. Okay. Let's try another one. Lots of practice here. We're all right. All right. 3. So we're looking at 3 right here. What is the limit from the left? At 3.
4.
4. What's the limit from the right at 3? What is the functional value at 3? Does the limit at 3 exist? It's also what? 4. Because if your left and your right are the same, then by theorem Bob, the limit at that point is also the same.
So for the last one, then it wouldn't exist.
Let me see here. I'm trying to find one. I don't like that one either. Let me see if I can get one. All right, let's get this one. -6. What's the limit from the left?
-2.
-2. What's the limit from the right? 1. What's the limit at -6? Doesn't exist, undefined. Why? Not the same, so by theorem, Bob, they're not the same. What about f of -6? Undefined, doesn't exist. Let's do another one. Let's say we're at 2. Let's look at 2. What is the limit from the right?
1. Is that there? Or is that 2?
I'm sorry, wrong one. You're right, it is there. I was thinking 3. Let's do 3. Sorry, you were correct. I was out the wrong number. At 3, what's the limit from the left at 3?
4.
4. What's the limit from the right?
4.
So what's the limit at 3?
4.
What's the functional value at 3?
6.
6. Yep, that's right. Making more sense? A little bit? Yeah, let's just try another one. See if I can find another one that's good. We haven't got to that yet. All right. I'll let you think about all 4 of these here, then we'll shout out the answers at the end. So we have what's the limit from the left at -6? -6. What's the limit from the left? What's the limit from the right? What's the limit at -6? And what's the functional value at -6? All right, limit from the left.
-3.
Limit from the right.
-3.
Limit at -6.
-3.
And the functional value.
-2.
-2. Okay. Now, let's say we go to -1. What's the limit from the left at -1?
-1.
From the left.
Oh, from the left. -3.
So what's from the right?
-1.
Are you seeing it now?
Yeah.
And what's the limit at -1?
Undefined.
Undefined, because by theorem, Bob, the left and the right are different. Do we have a functional value at -1? No, because, excuse me, no, because there's no closed circle. Okay? All right. This is more. We haven't got to the infinity ones yet, so I'm trying to skip those. So this one. What is the limit as x approaches -2 from the right? So what you have to think about is, from the right, do you use the top one or the bottom one for -2 from the right? So if here's -2, what is from the right? Is that going to be numbers bigger than 2 or less than 2? It's bigger. So is it going to be the top or the bottom?
Top.
Top, right? Because that's greater than -2. So you just put -2 into the top, and what do you get? -2 squared is 4 minus 1, you get -3, right? So the limit from the right would be -3 because you figure out which part you're using. Let's try another one. X, the limit as x approaches 4.
Bottom.
What? Now, let's do this. Once again, we have 4 things we want to consider. F of 4, x approaches 4, 4 4 from the left, 4 from the right. You have to consider all of those when you do this problem, okay? First off, what is f of 4? If you plug 4 in to go to the top of the bottom, which one includes 4? Bottom. So if we put 4 in there, we get 4 squared is 16, negative 16 and 10 is we get negative 6. Now, before we can just find the limit at 4, we need to consider the left and the right. So from the left, is it top or bottom?
Bottom.
Bottom. So if I put 4 in there, I get negative 6. What about if I put 4 in the top?
-6.
Negative 6. So since the left and the right are the same, what about the limit at 4?
-6.
It's negative 6, and it's the same thing. Now, hypothetically, let's say this was negative 5. If that would have been the answer, then this does not exist, right? Everything else could be the same. Okay. All right, I think we're getting it here. These are tricky. The math isn't super hard to do. It's just understanding what to do. You know what I mean? Are all of these 4? Every single one is like 4. All right. So what about that one? Limit of f of x as x approaches 1. I'll just let you think about that and all the stuff that we talked about. What is f of 1?
-5.
Negative 5. Put it in the top one, right? So as you approach from the left, that's going to be less than 1.
Also
Also negative 5. As you approach from the right, that's going to be greater than 1.
0.
Which is 0. So what is that answer? What's the limit at 1?
-5.
Doesn't exist. Why?
Because they're not the same.
So by what?
Bob.
By theorem Bob. By theorem Bob, these are different, so the limit does not exist. Look at this one just so we can kind of understand. Use the graph of the function in order to determine all the values of a where the limit as f of x as x approaches a is equal to 2. So what does that mean? So if we think of all the places that this function is equal to 2, the limit is equal to 2. So where would that be at? 6 would be equal to 2, right? Would the limit be equal to 2?
No.
The functional value, but what's the limit at 5?
-1.
-1. Because from the right and the left, it's the same. What about at -8? Is the limit equal to 2?
Yes.
Does the functional value equal 2? No. What about -2? Does the limit equal 2?
Yeah.
Does the functional value equal 2?
No.
Yes.
Yes. Okay, and then the final one. What about 0? Does the limit at 0 equal 2?
No.
Why?
Not the same.
The left and the right are not the same. What's the limit from the right?
2.
2. So from the right it is 2. From the left it is 5. So the limit at 0 doesn't exist because the left and right are not the same. And so by theorem Bob, it doesn't exist. So same thing here, but -1. And you can kind of see all the points. This is the limit at A. So at -7, there's a point at -1. Does the limit at -7 equal -1? No, because the left and the right are not the same. Does the limit at -6 equal -1? No. The limit is up here, right? Functional value is there. So that doesn't work. What about at -2? Does the limit at -2 equal -1? No. The one from the left does, but the one from the right does not. What about 6? Does the limit at 6 equal -1? Nope. Over here, the right does, the left doesn't. Okay? So one of the things with these problems you can see, especially when we're looking at the graph, and this homework is a lot of looking at the graphs to understand what you're doing. There's not a lot of like math you have to do. You know what I mean? It's looking at the graph. It's understanding what's going on, looking at the graph to kind of figure that out. Okay? All right. So let's look at this one. The limit of sine of x over x as x approaches 0. Now, if we just plug 0 in, what is sine of x? What is sine of 0? Where does the graph of sine start?
1. No, 0.
What do you think? Help them out. Where does the graph of sine start? Does sine start at 0 or sine start at 1?
1.
Or look at the unit circle. Sine's the y coordinate. So at 0, what's the y coordinate? 0. So sine of 0 is 0. So this gives you 0 over 0. And 0 over 0 means more work, right? We don't know what the answer is. So we want to look at 3 methods to be able to solve when we solve limits, okay? The first is numerically. This is just using a table of values. Okay, we'll come back and do each one of these individually. The second is graphically. That's how we were just doing it. And then the third is solving it analytically. We'll talk eventually about the sandwich theorem here, but for right now, it's just analytically. We'll come back to that. So this is by using the calculator, doing a table of values. This is by graphing it. And the last one's just analytically or algebraically, just using paper and pencil. And the one method for this one we'll use is called the sandwich theorem. Okay. All right, so let's do that and then we'll be done. So we're going to do numerical, we're going to go to the calculator. And I'm going to put, and you can just look here to see how this works. I'm going to do sine of x divided by x, and my y equals. And then I am going to go to the table. And you can see I have an error at 0, because if you put 0 in, you get 0 over 0, right? Now, one thing I can do here to help us out, I'm going to go over and I'm going to change this to ask. So watch what that does here. So I'm going to put in a number. If I put in 0, I get error. Let's put in a number close to 0. 0.1. I get 9983. Let's put in a number closer to 0. 0.001. I get, it says 1, but it's not 1. So let's put in a number closer to 0. Once again, it says 1, but it's not 1. But what's it appear as we get closer and closer to 0? This gets closer and closer to 1. Now, which way are we approaching 0, though? From
Right.
the right. Think about it here. If we're on the graph, where is 0.1 at?
On the right.
It's over here, right? So I'm putting in numbers over here, so we're approaching from the right. So to determine if it's truly 1, we also have to know what happens from the left. So I'd have to put in negative 0.1, negative 0.01, negative 0.0001. Is it working? Hope I got to prove it. Negative, there we go, 0.1, negative 0.01. Negative 0.001. And it appears the same thing's happening, right? From the left and the right. So we can say, from doing this, that this appears to be 1. Just from doing numerical guessing on using the table of values. Okay? All right. Homework. We'll continue with this tomorrow. Homework is this assignment here. Like I said, the first couple you can do. These bottom ones we haven't really got into yet. We got to finish the notes to get into some of these others that we haven't talked about yet. So, but you can at least probably start some of these at the top that we kind of did today. And some of them, if you look at them, you're like, yeah, I don't understand what that is. We'll get to those later.